Here I am going to explain and derive the Pythagoras theorem using the actually this proof is given by Euclid's. So this one is called as Euclid's proof of Pythagoras theorem. So actually you know that the statement of the Pythagoras theorem, in a right angle triangle, the square of the hypotenuse side is equal to the sum of the squares of the other two sides. So imagine that this one is the right angle triangle A, B, C. So you know that this one is at B is a right angle is there, and this one is the hypotenuse, and these are the perpendicular legs, we can say other two sides here. Now you can write this one here, AB square plus BC square is equal to AC square. This is called Pythagoras theorem. But here we want to prove that one the square of the hypotenuse equal to sum of the squares of other two sides. For this, Euclid took three squares mounted on the right angle triangle. So here the three squares mounted on a right angle triangle here. So you see that the ABC is a right angle triangle here. In this proof, here I am going to Euclid's proof. Before going to write here, there are three squares are there. This is 1, and this one is 2, and this one is the 3 squares on three sides of a right angle triangle ABC. Now how to show that area of the larger square is equal to the sum of the areas of other two squares. So here we can, what we have to prove here, the square of the area of the larger square. Area of the larger means its side is BC. So here BC square equal to AB square plus AC square. This one we have to prove. This one is same as the right angle triangle, means it is the Pythagoras theorem. So if you can show this one, BC square is equal to AB square plus AC square, so this one is the proof of the Pythagoras theorem here. Okay. For this we have to take some constructions of this one here actually. So construction part. In this construction, we have to take AL, we have to draw the AL, first one here, AL, draw AL perpendicular to DE and AL parallel to BD. AL is parallel to BD and perpendicular to DE. So this one is the first construction you have to do. Next, second one here, we have to join AD, join A comma D and F comma C. F comma C. These we have to. In the third case here, join A comma E and B comma I. So here we have to join AE and BI, and in the second A and D we have to join and F and C. So here we can see some triangles are formed here. Now This is the construction required to prove this theorem. Next, one more thing is required for that to prove this one. So actually the rectangle on the and the triangle on the same base between the same parallel lines, area of the triangle is half of the area of the rectangle. Here in this diagram already here diagram is there, so I am going to write here area of here the statement is there. This is the statement. In this statement here, if a triangle and the rectangle on the same base AB, and between the same parallel lines AB and DE, so then the area of the triangle is half of the area of the rectangle. This one how we can write here. So I am going to write area of rectangle AB CD is 2 times the area of the triangle ABE, triangle ABE, or in other words you can write area of triangle ABE is half of the area of rectangle ABCD. So this one, using these two construction and this concept, so you can prove this one easily. Now for this, first we have to consider the triangle FBC here. So what you have to consider? Triangle FBC. This is the one triangle here, FBC. This one is the one triangle. Then other triangle is here, ABD triangle. Consider triangle FBC, triangle ABD. We have to consider these two triangles. By observing these two triangles, we came to know that here FB is equal to AB, FB is equal to AB. These are the sides of a same square. Similarly, BC is equal to BD. Here this one is also side and this one also side. Then angle FBC, is equal to angle ABD is equal to 90 plus x degrees. Here you see this one is 90, this one is 90, angle at B is x degrees, so therefore this whole angle becomes here 90 plus x. This is the angle. So according to SCAS axiom, these two triangles are congruent. So therefore we can say triangle FBC congruent to triangle ABD. These two triangles are congruent. These triangles are congruent. Their areas are equal. Two congruent triangles have the equal area. So now next, here we have to use the concept, one more concept here. Now here you see FBC triangle is FBC triangle FBC and square FBAG are on the same base between same parallel lines, parallel lines. Whenever these are same parallel lines, we know that previously already I told that if the rectangle or the square, whatever it may be, a parallelogram on the same base between the same parallel lines, area of the triangle is half of the area of the parallelogram. Here the square also a parallelogram. Here we can write area of triangle FBC is half of the area of square FBAC. This one is. So you can take this one is 2. Now here you see similarly triangle, area of the triangle ABD, area of the triangle ABD is half of the area of BDLJ. So half of the area of BDL. So here BDLJ. Here you see this triangle and the rectangle on the same base BD. Same base BD. So this one is 3 you can take. Already you know that triangle FBC, ABD both are equal here. 2 and 3 actually 2 equal to 3. 2 equal to 3. So therefore you can write half area of FBAG equal to half area of BDLJ from 1 because 1 it says the two triangles are equal in area, so you can write the from 2 and 3. So now you can cancel this one and this one. So therefore the area of FBAG is equal to area of BDLJ. So you can take this one as the fourth one. Okay. Now we go for the another. Now we have to consider the triangles BCI. Now we have to consider triangle BCI and triangle ECA. Here you see these two triangles are congruent. How we can say means here you see BC is equal to here BC is equal to CEC and this one is the side. Here ICRCI is equal to AC. This one is also side. Angle BCI is equal to angle ECA. ECA is equal to 90 plus y degrees. So here this one is y degrees. From these two, here we can say triangle BCI congruent to triangle ECA. Okay. Now here you see we can according to the previous knowledge you can say that BCI area of triangle BCI is half of the area of. So here you see this triangle and the square here AC on the CIHA. So on the same base and between the same parallel lines. So here BCI is equal to means half of the area of AC IH. Okay, so this one you can take 5 and this one you can take 6, and now another one you can take, this one is ECA triangle, area of triangle ECA is half of the area of a rectangle. This one is, so here LECJ, this one is the rectangle and this one is 7. So now already you know that from 5, so area of BCI is equal to area of ECA, because these two are congruent. These are congruent. The congruent triangles have the equal area. So therefore from 6 and 7 we can write area of ACIH equal to area of LECJ, that is also a rectangle. So this one is 8. Okay. Now here you see, by adding this one is 4th and 8, 4 and 8, adding 4 and 8. So here we can take here adding 4th one and 8th one. So here we can write FBAG, area of FBAG, this one is the equal to area of BDLJ. This is the 4th one. And next, area of ACIH is equal to area of LECJ. This is the 8th one. Adding these two, so here adding these two, here you can write from 4 and 8. So adding these two, you can get area of FBAG plus area of ACIH equal to area of BDLJ plus area of LECJ. You know that one. Here this whole phenomena is equal to BD EC, area of BDEC. So therefore you can write area of FBAG plus area of ACIH is equal to area of, here we can write area of BDEC. This one is together we can write. So now what is the area of FBAG? That is AB square. And area of ACIH is here area of ACIH is equal to AC square equal to BDEC, area of BDEC is equal to BC square. So therefore we can write here BC square is equal to, here BC square is equal to AB square plus AC square. It means here square of the hypotenuse is equal to square of square of hypotenuse is equal to sum of the squares of other two sides. So therefore, this theorem is proved.